Hello, good morning, everyone. Everyone, mark your attendance. Okay, I start today class. In the previous class, uh, I covered up to I think representation of traffic flow. So once again, I see what are the various method by which we represent our traffic volume. So first method is annual average daily traffic. Annual average daily traffic is defined as the total number of vehicles throughout the year, and this vehicle count is done throughout the year for all the day. That means for 365 days, we count total number of vehicles and we divide by 365, then we get annual average daily traffic. Okay, next one is annual average hourly traffic. Annual average hourly traffic is defined as the total number of vehicles throughout the year by 365 into 24. That will be 365 by 365 by 24 vac into this will give us a unit in vehicle per hour because it is annual average hourly traffic. Now next one is I think annual average weekday traffic. So weekday means the day between Monday to Friday. The weekday means the day between Monday to Friday. So we do not count the weekend day for weekday traffic. That means for uh, Saturday and Sunday, we do not count the number of vehicle that pass on particular these 2 days. So throughout the year, we do not consider the whole Saturday and Sunday for our traffic count. So annual average weekday traffic is equal to total number of vehicle throughout weekday by 260. 260 will come in that manner like every every day have 22 big for a year. That means 52 big for a year. 52 into 5. That means for whole year, 52 Monday will camp, 52 Tuesday will camp, 52 Wednesday will camp, 52 Thursday, and so on. So we multiply 52 by 5, then we get 260. And also, annual average weekday traffic will come in the unit of vehicle per day. So Annual average big day traffic is greater than annual average daily traffic. Okay, now once here we see our annual average big traffic is greater than annual average daily traffic, because for annual average big day traffic we count the traffic volume for 260 day, and this 260 day traffic is more than the 365 day traffic. So here in annual average daily traffic counting, more number of days are involved with less number of traffic volume which already counted in Saturday Sunday days. So our annual average daily traffic will come less than annual average big day traffic. Now next one is average daily traffic. Average daily traffic will we find for 3 days also, for 5 days also, for 7 days also. But here we find annual average daily traffic for a particular week. So here we see total number of vehicle throughout a week by 7. Its unit comes also in vehicle per day. Here average daily traffic is also greater than annual average daily traffic, which have shown same region data of annual average week traffic and annual average daily traffic. Now uh, next one, move further, move further. Yeah, trend chart. Next one is trend chart. Trend chart is defined as traffic volume data can be represented in the form trend chart, which is useful in estimating the rate of growth of traffic of a particular class, that can be used for planning, future expansion, design, and regulation. So it will be defined as traffic volume data. Traffic volume data can be represented in the form of trend chart. Traffic volume data can be represented in the form of trend chart, which is useful in estimating the rate of growth, the rate of growth, the rate of growth of traffic of a particular class, traffic of a particular class, that can be used for planning, future expansion, design, and regulation. That means when we in previous method, they are mathematical method by which we represent our traffic volume, but trend chart and so many methods, so which we discuss later, are also different type of representation of our traffic volume, and these representations are fully graphical representation, and all the points which involved in trend charts are discussed. mm, that like uh, traffic volume data can be represented in from trend chart, which is how obvious, because our traffic volume data can be represented with the help of trend chart. Also mathematical forms are also available with us. So trend chart, through trend chart we estimate the rate of growth of traffic of a particular class. That means we find out how our traffic uh, will grow, and how these traffic will involve in a particular class, and how the rate of growth of our traffic. By knowing the rate of growth of traffic, we estimate our future expansion, and we do our designing, regulation parts, all the parts which are involved by seeing rate of growth of future. Okay, uh, now next, if from trend chart rate of growth of traffic volume is computed to be r%, if rate of growth of traffic volume, which is obvious, uh, uh, which is also designated as r%, because we already discussed all the things in environmental engineering, because in environmental engineering also we find future population forecasts and we have different methods to find out future population forecasting. So in same manner we find out our future expansion for traffic. So uh, here rate of growth of traffic volume is computed to be r%, then our future expansion is given by, then our future expansion, that means future traffic, is given by q is equal to q naught 1 plus r to the power n, where q is equal to the year for which our traffic volume is to be uh, needed, and q naught is equal to present traffic, and r is equal to rate of growth, matlab percentage rate of growth, and n is equal to particular year for which our traffic volume counted will be needed. So all abbreviation which is important are discussed below. Here we see, uh, just wait, here q is equal to q naught 1 plus r to the power n, where q is equal to future traffic volume and q naught is equal to present traffic volume and n is equal to number of years. So that means q is equal to future traffic volume, the year for which we required our future traffic. q naught is equal to present traffic volume, that means last known traffic volume, and n is equal to number of years after which traffic is required. N is equal to number of year after which after which year after after which after which traffic is required, after which traffic is required. After which traffic is required, and r is equal to, here r is equal to rate of growth, r is equal to percentage or rate of growth, percentage rate of growth. Percentage rate of growth. Now how trend chart will be drawn? So just see trend chart drawn as this is our, just a bit, increase our y-axis. This is our y-axis and this one is our x-axis, and on x-axis we plot our time in years, time in years, and on y-axis we plot annual average daily traffic. Annual average daily traffic. On y-axis, I plot annual average daily traffic, and on x-axis, we plot our time or years. Now, uh, let us suppose for 2000, start with 2010. 2010, 2011, 2012, 2013, 2014, and so on. Just mark 2011, 2012, 2013, 2014. Now use another color. Okay, just I see this is annual average daily traffic for 2010, and our graph will vary like this. So here, just wait, our graph will vary like this. So here we join our time, that means the year, with annual average daily traffic. Here also be 2012. I add with annual average daily traffic. For 2013 also we add annual average daily traffic mark. Now from here we also find out the dx value. This is our dx value, this is our dx value, this is our dx value, this is our dx value. So this is our dx, this is our dx. The diagram is not on a scale. This is our dx value, this is also our dx value, this is our dy, this is our dy, this is also our dy, this is also our dy. So here all dy by dx, so here all dy by dx, so all dy by dx, all dy by dx will give us percentage rate of growth. This will give us percentage r. So this is the traffic volume trend for last last 5 years. This is traffic volume TV, traffic volume trend of traffic volume trend of last 5 years. This is traffic volume trend of last 5 years. And by knowing this traffic volume trend for last year, we find out for next year also, and so on. So this is also a method, graphical method for finding our traffic volume. Now move toward next method or next representation. So just wait. So this is our annual average daily traffic representation, which I already represent annual average daily traffic 2010, 11, 12, and 13, and so on, which I already discussed. Now, next method and next graphical method for representation of traffic volume. It is known as variation chart. And how variation chart will define? Variation chart is variation chart. Variation chart can be used to show hourly, daily, or seasonal variation of traffic volume over a particular section of road. These chart help in deciding the facility. These chart help in deciding the facility and variation chart. Just wait. Variation chart. Variation chart can be used to show hourly. It will show hourly, daily, or seasonal variation of traffic volume. That means how our traffic volume will vary with hour, with day, or with season over particular section of road. We find all these things with our variation chart. This chart helps in deciding the facility. The charts help in deciding the facility. Just wait. The chart helps in deciding the facility and regulation needed during peak traffic period. So, by knowing variation charts, we decide our various facilities and the traffic regulation which will needed during our peak traffic period. And peak traffic period may be for a peak day, for peak seasons. So, by seeing our variation chart, we show our hourly, daily, or seasonal variations of traffic volume. And by knowing all these traffic volume for various hour, daily, and seasonal uh, things, we decide and regulate our traffic accordingly. And just wait, below our variation chart is also shown. This is the variation chart. This is our variation chart. This is our variation chart. On y-axis, we have vehicle per hour. Vehicle per hour, that means our traffic volume. Our traffic volume is also represented on y-axis. Traffic volume as same as that of uh, our trend chart. But in trend chart, we represent traffic volume in terms of annual average daily traffic. This is our traffic volume. This is our traffic volume. On y-axis, this is q value, q. This is q value, and our q is represented in vehicle per hour. And on x-axis, we represented time. We represent our time, and time is in hour. Time is in hour. So this is a variation chart for a particular day. We start from 6 a.m. Just see here, we start from 6 a.m. and end for 6 a.m. So this is the variation for our 24 hours. This is the variation of our 24 hours. So here I see from 6 a.m. our traffic volume is less. for 24 hours. Variation chart for 24 hours. From 6 a.m. morning, our traffic volume is less. On 7 a.m., traffic volume just increases. On 8 a.m., our traffic volume is increases, and so on. Our traffic volume is increases up to 10 or 11, whichever. Now our traffic volume is decreases on afternoon, and also here I see our traffic volume will gradually increases during evening time and also during night time, and uh, on 5 a.m. or 6 a.m. morning, our traffic volume will be decreases. So this is a variation chart of our traffic volume. From this variation chart, we see how our traffic volume will vary with hourly, daily, or seasonal basis. So, which helps us to decide and facilitate regulation needed during our uh, peak hours. So this is also another method. This is also another graphical method to represent our traffic volume. Now, next one is that means we cover up to here. We cover four mathematical relations for traffic volume representation and two graphical method for representation of our traffic volume. First one is trend chart. Second one is what? Second one is our variation chart. And now move toward next. Next one is traffic flow map. Just wait. Now the next method is traffic flow map. So traffic flow map. Just wait. What is a traffic flow map? Traffic flow map. These maps along the routes indicate the volume of traffic flowing through them. So traffic volume map is basically a map which will indicates the volume of traffic which will flowing through that routes or that particular stretch or that particular road or that particular lane. So this is just like our Google map. On Google map we see how the traffic will move, where the area is congested, which will show with different colors. Like red color we see on that route our traffic will be mm, in congestion mode. So accordingly we have a traffic flow map. On that map we find the volume of traffic which will flowing through that routes or flowing through that routes. Now the main point is the thickness of line. The thickness of line, which line, which will shown in traffic flow map. The thickness of this line represents the traffic volume to any desired scale. That means the thickness of line which will be in traffic flow map represent the traffic volume to any desired scale. That means we plot our traffic volume map, and on traffic volume map we represent different lines, and the thickness of lines will represent how the traffic volume will be present in that particular route or on that particular lane or on that particular road. So if we draw the diagram, then obviously all things will be clear. Now next, this helps to find the traffic volume distribution along the existing road at a glance. That means see, this helps to find what traffic flow map helps to find the traffic volume distribution along the existing road at a glance. That means how our traffic volume will be distributed on that road we find through traffic flow map. just just I show you all the things. Just wait. uh, clear, all right. Okay, suppose we have a road network. Suppose we have a road network. Select a city like Chaiwasa, city like Chaiwasa, city like Chaiwasa. These are the different blocks of our city, and for showing traffic flow map, we just wait. We so here our roads. This is our road. This is our road. This is our road. Here we see our this is our road. This is our road, road 1, and also this is another road. Just wait. This is another road. This is another road. This is another road. This is road 2. Road 2. Here we see the thickness of road 1 is much more than the thickness of road 2. So more traffic volume will flow on road 1 with respect to road 2, because traffic flow map indicates the thickness of line represents the traffic volume. So we see the thickness of line in road 1 is greater than the thickness of line of road 2. So more traffic volume will flow in road 1. So accordingly, we see the thickness of roads and we find out the traffic volume by helping traffic flow map. Now next, how we represent our traffic volume. Next one is, so these all are our roads. These all are our roads. This is road 1. This is the road 1, which Suppose we consider this is our road 1 and the road 1 have more thickness. Also this road have more thickness than the previous one. This is another type of road. 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 So by seeing the thickness of these roads, we find out the traffic volume. So how many vehicle flow through a given section per unit time. Now, next method. Next one is traffic. Next one is traffic volume flow diagram. Volume flow diagram at intersection. Volume flow diagram. Volume flow diagram at intersection. Volume flow diagram. So, particular this diagram will help to decide our rotary design, which we discuss later. So, volume flow diagram at intersection, either drawn to a certain scale or indicating traffic volume, can be used. Find the details of crossing and turning vehicle. So, basically, volume flow diagram is done at intersection point to show how many traffic volume can be cross our intersection or how many vehicle will turn our intersection. These details are required for designing of intersection. So obviously these all things, these all details are required to us to find out and to design our intersection, which we will discuss later. Now next this is the representation of our traffic volume. This is the representation of our traffic volume flow diagram at intersection. So here we see this is our intersection point where all the vehicles in different direction will come and meet with each other. From this particular lane, just wait. From this particular lane, I have see 1140. 1140 vehicle will come towards the intersection. So total number of here total entering vehicle is 1140 and I think 1600 and 730 and 360 and 1200. So these all vehicles will enter towards the intersection. Now from 1200 vehicle, 80 vehicle will turn right and 1000 vehicle will go in a straight mode and another 40 vehicle will turn towards left and same uh, cases happen for these vehicles. Out of 1140 vehicle, 620 vehicle will go in straight and 440 number of vehicle will going left and 80 vehicle will come right. Now from 1600 number of vehicle, 18 vehicle will come left, 500 vehicle will come right and 1200 will vehicle came straight. Out of 360 vehicle, 100 vehicle will come left, 200 vehicle will go straight and 60 vehicle and 60 vehicle will come and 60 vehicle will come at our left support.